Students, welcome to our video lecture. Today we are going to do two specific type of integrals. And students, in this specific type of integrals we have specific type of formulas to be applied. Say our first type of integral is type 1 integration dx upon quadratic. And type 2 is dx upon root of quadratic. Today, students, I am going to discuss this type of integrals only. So our first target is to do dx upon quadratic. For that we have question number 11 and MCQ 24, which I am focusing on. 7.4. Question number 11. It is dx upon 9x squared plus 6x plus 5 and 24 dx upon x squared plus twice x plus 2. Unfortunately, we have only one sum of dx upon quadratic, and then students directly we have MCQ. Now, students, in this type of sums, here we have to be very cautious and we go very slow according to some directed algorithmic steps. First step in this type of question, it is of type 1 dx upon quadratic. Students, try to make coefficient of x squared as plus 1. To get coefficient of x squared as 1, I have to take 9 common from the denominator. So this leaves me 1 by 9. Integration dx upon x squared, 6 by 9, so 2 by 3x plus 5 by 9. Go in a systematic algorithmic approach, students. Here you will then never make mistakes. Third step, taking x squared as the first term and 2 by 3x as the middle term, find out last term to complete a perfect square. So last term is equal to middle term square upon 4 into first. Last term is equal to middle term square upon 4 into first term. So square of 2 by 3x is 4x squared by 9 upon 4 into x squared. So this is 1 by 9. So to complete a perfect square, students, add and subtract the last term, which is here 1 by 9, keeping 5 by 9 as a constant as it is. So this is our step number 3. Step number 2 was to complete a perfect square, taking x squared as first term and 2 by 3x as middle term. And in the first step, actually we are doing, students, or we are making coefficient of x squared. Okay, now students, this is written as 1 by 9 integration dx upon, this is square of x plus 1 by 3, and this is 4 by 9, which is written as square of 2 by 3. Yes or no? So I am going to apply this formula. I am writing here integration dx upon x plus p the whole square plus a square is 1 by a tan inverse of x plus p by a plus c. I can write px plus q also. So I am writing this as 1 by 9 into 1 by h 2 by 3, so reciprocal is 3 by 2. Tan inverse of x plus 1 by 3 upon 2 by 3 plus c. So this is 3 1s are 3 2. So 1 by 6 tan inverse of 2x plus 1 sorry 3x plus 1 upon 2 plus 8 3 is LC. So this is the final answer. So this type of sum students need an algorithmic approach, and once students will develop that approach, I don't think students should face any problem. This is again very easy. Students, very easy. Okay, here already coefficient of x square is 1. Complete a perfect square by taking x square as first term and twice x as middle term. Last term is equal to middle term square upon 4 into first term. 2x square is 4x square upon 4x square. So this is 1. So to complete a perfect square, add and subtract 1. So this changes to integration dx upon x plus 1 the whole square plus 1 square. Apply the same formula. P is 1 and A is also 1. 1 by 1 is 1. So I am not writing. This is tan inverse x plus 1 by 1 plus c. So the correct option is option B. So this is how, students, we do integral of type 1, and it is nothing but dx upon quadratic. Students, it is nothing but dx upon quadratic. This is what we have to write. That's all, students. Unfortunately, only 2 sums we have of this type. But this is the subtype in the next type which we are going to do in the next lecture. So this is very basic. This is used in many advanced application of integrals, especially chapter number 8 also. Now students, we are doing next type of integral, and that is dx upon root of quadratic. Our next type is, students, dx upon root of quadratic. For that, I am doing questions 10, 12, and 13. Question number 10 of 7.4. It is integration dx upon square root of x square plus 2x plus 2. Then, doing the 12th question. 11th already we have done. It is dx upon square root of 7 minus 6x minus x square. And the 13th question also I am writing. It is dx upon square root of x minus 1 into students x minus 2. So this is what we are focusing upon. Concept is same. Make coefficient of x square 1. It is already 1. So I will complete the perfect square by taking x square as first term and twice x as middle term. So last term is equal to middle term square upon 4 into first term. And so this is written as 4x square upon 4x square, which is 1. So students, I am writing this as integration dx upon square root of x square plus twice x plus 1, keeping 2 as it is and subtracting 1. So here the formula which I am going to apply is integration dx upon under root of x square plus or minus a square is log mod x plus under root x square plus or minus a square plus c. So this is written as dx upon square root of x plus 1 whole square plus 1 square. It is under root x square plus a square. So this is log mod. Instead of x, write x plus 1. Here we can directly write the given integrand. That is the general tradition. To write the answer. So students, this is our answer. Now, whenever we have a root of quadratic and if coefficient of x square is negative, then I cannot take minus sign common inside square root. If it was without square root, I would have taken it. But I cannot take a minus sign common, students, inside square root. Otherwise it will become complex. So keeping minus x square as x and minus 6x, I am operating the last term. So the last term is equal to middle term square upon 4 into first term. Minus 6x square is 36x square and this will be minus 4x square, which will give us minus 9. Where I can add and subtract 9, is it done? So the integral becomes dx upon square root of 9 plus 7 minus 9 minus 6x minus x square. So this is equal to integration dx upon under root of 16 minus x plus 3 the whole square. If I take minus sign common here, this terms will change to plus. And 16 is also written as 4 square. So here I am applying, students, the formula integration dx upon under root a square minus x square is sine inverse of x by a plus c. So this answer is nothing but sine inverse of x plus 3 by 4 plus c. So be very careful about the thing that within the square root, students, I cannot take minus sign common, because negative within a root will be complex. Be very careful, students, about that aspect. Okay, 13th sum. I am expanding the terms which will give me square root of x square minus 3x plus 2. This all of you know. Second step, operate and find out last term. It is middle term square upon 4 into first term. Now I am avoiding the right formula. Adding and subtracting 9 by 4, we get x square minus 3x plus 9 by 4 plus 2 minus 9 by 4. So this is the square of x minus 3 by 2. So square root of x minus 3 by 2 the whole square, and this is minus 1 by 4. So it is minus 1 by 2 the whole square under root x square minus a square. So log mod x minus 3 by 2 plus under root of derivative and integrand plus 3 students. This is the answer. So again I am re-emphasizing, this is very interesting. once you understand. And for this, you have to follow the algorithm which I have explained. So remember, this type of questions are very important for advanced sums of integral. So students, one have to be very careful in applying the formulas. Okay students, the next set of sums are 14, 15. Question 14, 15. Integral dx upon square root of 8 plus 3x minus x squared. And the 15th question is integral dx upon square root of x minus a into x minus b. Okay, and then we do students MCQ 25. Okay students, all of you please concentrate. Inside square negative, so be careful, directly find the last term. And that last term will be middle term square, which is 9 square, upon 4 into first term, and that is nothing but minus 9 by 4. So add and subtract 9 by 4 within square root. I hope all of you understood this. Now last term is middle term square upon 4 into first term, and that I suppose students all of you have perfectly understood. Now 9 by 4 plus 8, 32 plus 9, 41 by 4. And here taking minus sign common, x square minus 3x plus 9 by 4. Now I am converting this to a standard form, which is dx upon square root of root 41 by 2, the whole square, minus, this is x minus 3 by 2 square, whole square into 7. So which formula? A square minus x square. So sine inverse of x by a. So the answer is sine inverse of x minus 3 by 2 upon root 41 by 2 plus c. So this is converted as sine inverse of twice x minus 3 by root 41 plus c, taking 2 as LCM. Now here students, I go for simple expansion which gives me dx upon under root of x square minus x into a plus b plus a into b. Simple expansion of the bracket students, x minus a into x minus b. Now go for finding the last term. What is the formula to find last term? Middle term square upon 4 into first term. So this is a plus b by 2 the whole square. Or even I can keep a plus b the whole square by 4. Next add and subtract the last term within the square root. So dx upon under root of x square minus x into a plus b plus a plus b the whole square by 4 plus ab minus a plus b the whole square by 4. The simplification of this much will be what? Then the answer is, if I take LCM, this will be 4ab minus a square minus 2ab minus b square. So minus a square minus 4ab, this will be minus a square minus 2ab minus b square. When I operate the negatives, so 4ab minus 2ab is plus 2ab. So it will be, you can say, when I take minus sign common, I will get a minus b the whole square by 4. Just pay attention. 4ab minus a square minus 2ab minus b square by 4, which is simplified as this. That I am going to write. So this is rewritten as dx upon under root of x minus a plus b by 2 the whole square minus a minus b by 2 the whole square. This is what I am trying to emphasize, because this will be, this is minus, this is plus. Middle terms will change to minus. Now under root of x square minus a square, so log mod x minus a plus b by 2 plus under root of directly the integrand plus c. This is our answer, students. I hope all of you have understood. So students, you have by the time understood this type of questions. Now one more sum, students, and that is MCQ 25 will be complete. Then the remaining time will start in the next lecture, students. Yes, students, it is MCQ 25. Integral of dx upon square root of 9x minus 4x square. This, students, we are going to deal with. Again, a negative sign with x square, so don't take anything common. Directly operate last term. The formula for last term is middle term square upon 4 into first term. So this comes out to be minus of 81 by 16. So in the next step, add and subtract the last term. So 81 by 16 minus 81 by 16. No constant term is given in the given integrand. Students, we are not given any constant term. Fair enough. This is written as dx upon under root of 81 by 16, taking minus sign common. 4x square minus 9x plus 81 by 16. I am writing here, students. This is rewritten as dx upon under root of 9 by 4 the whole square minus 2x minus 9 by 4 the whole square. This is square of 2x minus 9 by 4, because whenever middle term is negative, there will be a negative sign between the terms. Under root a square minus x square, so this is sine inverse x by a. Sine inverse of 2x minus 9 by 4 upon 9 by 4, but don't forget to divide by the coefficient of x. Otherwise, your entire sum will be definitely wrong. If we forget to divide, students, by the coefficient of x. Our sum will be long. Taking 4 as LCM, this changes to 1 by 2 sine inverse of 8x minus 9 upon 9 plus 3, which is our answer. And according to the option, it is B. Our next two type will be linear upon quadratic and linear upon root quadratic, which will have as a subpart dx upon quadratic or dx upon root of quadratic. That is why, students, today I am stopping with these two types, dx upon quadratic and dx upon root of quadratic. I am stopping here, students, because the new type I will definitely take in the next lecture, and that type or these two types are 5 marks. And these are very easy based on this base, students. So we stop here and we will do the remaining two types in the next lecture. Thank you, students.